Alright guys, so we have January 2018 paper that we're going to take a look at now. See, we have our formula sheet. And the first question here, and I know that this paper is a little bit blurry, but this here is actually a divide sign. Yeah? So this first question here is actually 5.5 divided by 3 and 2 over 3. And they say you could use your calculator for this, and in terms of punching this in on your calculator, you'll definitely want to use brackets. So you'll have to, there is this button here, A into B over C, and so you'll have to press that button when you're doing your fraction. So what you want to do in your calculator is press open brackets and type 5 and the button 1 and the button 2, right? So that's 5.5. Then you could press divide and then press 3, the button 2 and the button 3. So we have 3 and 2/3. Then you close your brackets and you can actually put plus here 1 and 4 over 5. So this is how it would look if you type it in correctly in your calculator. And the answer we get here is equal to 3 and 3 over 10. Now similarly on the calculator, we would want to use brackets for this one. Please always use brackets when you're using a calculator. It really helps, right? So I'll just punch in 165, multiply, I'll open my brackets and put 0.38, and I'll close my brackets and put squared, right? So just in case the calculator thinks it's 8 squared I'm talking about, no, it's 0.38 squared. So when I do that, the answer that I get here is 165. The exact answer being 23.826. Now we have 23.826 being the exact answer, 0.826. And they want it to 2 decimal places, well that'll be 23.83. 3 significant figures will be 23.8, and the nearest whole number will actually be 24. Mr. Adams invested $5,000 at a credit union and received $5,810 inclusive of simple interest after 3 years. Okay, so I'm now seeing that this is a simple interest question. So before I even read further, I'm going to write my formula at the side there so that I don't have to remember it later. Principal by rate by time over 100, right? So we could see here that this here, after 3 years, he received $5,810. So therefore, his interest is $810 over 3 years, right? So determine the simple interest learned. So that simple is really just 5,000 minus 5,810 to give us $810. Part 2, the annual interest rate paid by the credit union. So we see here that the simple interest is $810. That is equal to the principal, which is 5,000, times the rate, which is what we want to find, times the time, 3 years, all over 100. So now we could carry the 100 across, so it'll be 100 multiplied by 810, and that'll be equal to, well, let's just multiply this 3 by this 5, so we'll have 15,000 here, R, which is multiplied by the rate, And now I could throw the 15,000 over. So now I have R is equal to, well, let's just multiply this here, 810 plus 2 additional zeros. So that's 81,000 divided by the 15,000. And that will give us 5.4. So the rate is 5.4%. So the rate is 5.4%. The length of time it will take for Mr. Adams to investment to be doubled at the same rate of interest. So to be doubled means that he would have to get back $10,000, right? He'll have to get back $10,000. That means that he would have to have an interest of $5,000. That's how much he got back in order to double his initial $5,000, right? So the simple interest he would have received would have been $5,000, and they're asking for how much time now. So that is the principal, 5,000 times the rate, which is 5.4. We just worked that out. Multiply by time t all over 100, right? So let's just carry this 100 across. So we'll now have 5,000 multiplied by 100, and that is equal to, well, 5,000 times 5.4 gives us 27,000 on this side, t, right? So now we could see here that t would be 500,000 divided, because when we throw this 27 across, it'll be divided by 27,000. So that will give us 18.5 years. So it will take 18.5 years for him to double his investment. So now we're talking about a little bit of algebra, and we have here question 2a. Given that a operation b, and this is an operation question, means a plus 4b, the square root of that, where the positive root is taken, determine the value of 1 operation 2. So 1 operation 2, well, I'll just put, well, this 1 is in the place of a, and the 2 is in the place of b. So I'll just put 1 wherever I'm seeing a and b. So it would be the square root of 1 plus 4 by b, which is 2. So that means that it's the square root of 4 2s are 8 and 1 is 9. And that means that it is, and they say we'll take the positive root here is taken to be positive 3. Whether the operation denoted by that is commutative. Justify your answer. Well, is this commutative? Commutative meaning, right, that if we will have the operation A operation B, will that be the same as B operation A? And that's what we mean by commutative there. So let's try B operation A. So I will put B operation A, in this case, will be 2 operation 1. And remember, the original is A plus 4B, so let's just write it here on the side, A plus 4B. Right. So now I will take this and put this into the equation. Well, now you can see that this now is in the place of A, and this now is in the place of B. So let's see if it works, right? If we'll get the same thing. So therefore, that'll be the square root of 2 plus 4 into 1. And that is equal to the square root of 4 plus 2 is 6. So we can leave that as the square root of 6 and say that no, this is not commutative. Okay, so we have to solve this inequality, and so we will have 3 minus 2x is greater than 5, I could easily throw this 3 across here, so I'll have negative 2x is greater than 5. 5 minus 3, therefore negative 2x is greater than positive 2. And of course, when I throw this negative 2 across, because it's a negative means that x, we have to change the sign. So 2 divided by negative 2. So x is less than negative 1. And now we have to represent the answer there. Well, for x to be less than negative 1, we draw a clear circle around negative 1 and an arrow in this direction here. And that will represent x is less than negative 1. Remember, if it was less than or equal to, then we would have to put a shaded circle. So, statement 1, 2 adult tickets and 3 child tickets cost $43. So I could, do this in algebra one time, right? 2 adult tickets plus 3 child tickets cost $43. And you notice I didn't even read the rest of the question yet. 1 adult ticket plus 1 child ticket costs, one child ticket, C, costs $18.50, right? Let x express the cost of an adult ticket and y express the cost of a child ticket. Write 2 equations in x and y to represent the information above. So we can see here, let x represent the cost of an adult ticket and y will represent the child ticket. That'll be 43. And now we will have here x plus y is equal to 1850. Or we can leave it at 18.5, no problem. But yeah, that'll be it. Solve the equations to determine the cost of an adult ticket. So we're basically gonna solve the equations simultaneously. And what we want to do is we want to really get the value for x is what we're looking for. That's the cost of an adult ticket, right? So what do we have here? 2x plus 3y is 43. So I will write it over 2x plus 3y equals 43. And please make note of the story that I'm telling. X plus y is 1850. X plus y is 1850. All right, let's call this 1, let's call this 2. So therefore from 2, we could say that x, which is what we want to find, is equal to 1850 minus y. And we'll sub in 1. So that means therefore 2 into 1850 minus y, 18.5 minus y, yeah, plus 3y is equal to 43. Well, you know, we could have actually just done for y. Actually, we didn't really have to. We could have gone y is equal to 1850 minus x, and we would have been able to find for x one time. So I guess we didn't really have to find for y, but since we're here, let's just finish it off, right? So 2 times 18.5 gives us 37. So that's 37 minus 2y plus 3y is equal to 43. So now let's throw the 37 across, and of course negative 2y plus 3y will just be 1y, and that will be 43 minus 37. So 43 minus 37 ends up being 6. So when y is 6, x is equal to 1850 minus 6, which will be 1250. So, and I will make my last statement, therefore, cost of an adult ticket equals X equals $12.50. So we have set theory here, and the universal set, we could see it's B, D, E, F, G, I, K, S, T, V, W. The Venn diagram below shows U and 3 sets M, P, and R, which are the subsets of U. So, okay, state the value of the order of, or the number of elements in P union R. So P union R means that I want everything in P as well as everything in R. So this here will be P union R. So the number n, the cardinal number, or the number of elements in P union R, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 elements. List the members of M intersect P. So M intersect P, we can see that this is M, and this is where M intersects P, and the elements are B and D. And M union R complement. So that means that I want everything in M, yes, but I don't want nothing from R. So this is R here, so I want everything in M, but nothing from R. So that would mean K and B. And just to be very, just to be mathematically correct, the members, this is list the members, so we could put M intersect P being the set of B and D, and M union R complement is the set of. Let's just have good manners when we do our maths, right? Using a ruler, a pencil, and a pair of compasses, construct the triangle PQR with PQ 8 centimeters. PQR is 120 degrees and the QR is 5 centimeters. So the first thing I will do in this is draw a sketch so that you'll have an idea of what this thing is going to look like. So we see here that PQ is 8 centimeters. So let's call this P and let's call this Q. Right? And we have 8 centimeters here. PQR is 120 degrees. So that is quite a lot. That's like that, 120. So that means that R is here, right? And then QR is 5 centimeters. So this here is 5 centimeters, right? And then we have this length over here. And so now we have a sketch of what we want. Now remember that we don't really know how to construct a 120 degree, but we do know how to construct a 60 degree. And since this here will be 60 in order to make up the 180, 6, 7, 8. So we can construct a 60 degree in this way from the point P here in that direction, right? So I don't really have any tools in terms of straight line tools here. So I will just actually just do the sketch and work through the, I'll just do a sketch and work through the procedure for you guys, right? So the first thing you'll want to do is draw a very long line, much longer than the 8 centimeters you would need. Then you would need to mark off a point P. Put your compass on the point P. Open the compass to 8 centimeters and then cut over here, and that will be the point Q. Put the compass right here and then cut back here on P just to make sure. And make sure you label it 8 centimeters. Now we want to construct a 60 degree angle from the point Q. So I'll come here, put my put my compass point right here, open it to any length, and I'll cut a big arc like this, right? I will keep the same compass opening, and I'll come from this point and I'll cut an arc this way, and this will give me my 60-degree angle, and I will draw it like that all the way up. Then now I will come here and put my point back on Q. I will open my compass to 5 centimeters and cut the arc here to give me R. This is the point R, and this will be 5 centimeters, right? So this is 5 centimeters, this is 60 degrees. That means that this is 120 degrees. All you would need to do is take your ruler and join P and R like that, and you would have your construction. Measure and state the length of the side PR. Well, I did not do it to scale, so let me actually go and just do it on a piece of paper, and I'll measure the angle and I'll get back to you. So measure and state the length of the side of PR. Well, I did not really do it to scale, so me measuring this wouldn't really make sense. But you could just measure it with your ruler and see what you get, right? On the diagram B1, construct the point S such that PQRS forms a parallelogram, right? So obviously we want the point S somewhere up here so that PQRS forms a parallelogram. So what we would have to do is we would have to construct another 60 degree just like this, but we will have to do it from the point P, right? Construct a 60 degree from the point P. So let's do that first. So I'll put my compass at the point P, and then I will open it to any length and cut an arc like that. And then I'll put the compass here, and with the same length I will cut an arc this way, and now I will have my 60 degree. And then I will put the compass back on P over here. I will open the compass to measure it 5 centimeters, and I will cut an arc over here, and the point S will probably end up somewhere like that, or maybe not. Mine didn't really look too parallel, but you know, it should join if it is that you did your 5 centimeters here. So in terms of doing a parallelogram, you just have to construct another 60 degree here, and then draw the line up and measure 5 centimeters, and it would have joined S to R right there, right? So you would have, you would have ended up with something looking like this, and these are the construction lines that you would have expected to have, including one right here for when you measured S. Remember, all of these construction lines is you will be getting marks for, and we can see here that there are 4 marks for the original construction, and then an additional 2 marks for the parallelogram construction, right? The equation of a straight line is given by that. Well, the first thing I notice is not in the form y is equal to mx plus c. And this is the thing, is that I have all of the things on my cheat sheet in my mind. The minute I see the equation of a line, I am thinking about all of the stuff on my cheat sheet that I should remember. The equation of the line L in the form y is equal to mx plus c. Well, this, we see that we want it in the form y is equal to mx plus c. So we have here 3x minus 4y is equal to 5. You see, we started with the original question so that they know where we start, and then we'll start to work. I'll throw this across here, so I will get negative 4y is equal to 5 minus 3x. But of course I want the x first for it to be in mx plus c. So negative 4y is equal to negative 3x plus 5. This is more looks like mx plus c. And then when I throw the 4 across, I will end up get my final answer. Well, 4 is going to divide everything over here, negative 4. But that means that the negative 4 is the denominator of the 3x as well as the 5, right? So when we put negative 4 under there, right, Well, I'll just put it and see 3x plus 5 under negative 4. So that means that these two are going to cancel. So the final answer is going to be y is equal to the negative 3 and the negative 4. Those negatives are going to cancel. So I'll just end up with 3 on 4x, right? Plus, well, this negative 4 here is going to make that 5 a negative. So it wouldn't be plus, it'll be minus 5 on 4. And so this here, and we will be gentlemen about it, and we will put is of the form y is equal to mx plus c, where m equals 3 over 4 and c equals negative 5 over 4. Hence, determine the gradient of the line. Well, 1 mark, we already said m is equal to 3 over 4. The gradient m. The point P with coordinates r and 2 lies on the line. Determine the value of r. So we don't actually have to use this equation in order to determine the value of r. We could actually use the original equation, 3x minus 4y is equal to 5. So 3x minus 4y is equal to 5. And we see here that the point P at P is R2. So we could see here that the R is actually the x value and 2 is actually the y value. So we could sub that, therefore 3, and we'll sub R for the x value minus 4, we'll sub 2 for the y value is equal to 5, right? So 3R minus 8 is equal to 5. 3R is equal to 5 plus 8. 3R is equal to 13. 13. Therefore, R is equal to 13 on 3. And as much as possible, you would want to put, and please try your best to put all of your answers in fraction form. It might not always be possible, like for number 1 part B, where we had multiply by 10 to the negative 2. So in those cases, you might need to put decimals, but as much as possible, try to avoid decimals, because fractions are always a more exact answer, or the most exact answer. So we have here r being 4 1/3, and find the equation of the straight line passing through the point 60, which is perpendicular to L. So it being perpendicular to L, well, let's go back to the actual equation, mx plus c, 3 over 4x minus 5 over 4. So 3 over 4 x minus 5 over 4, and that is y is equal to mx plus c. This is the line L, right? And so the line perpendicular to L, right? Perpendicular to L would imply that m1 multiplied by m2 is equal to -1. So that line, the gradient of that line, because it's perpendicular to L, means that if I multiply both of their gradients, I will get -1. So that means that if I take the gradient of the line L and multiply it by the gradient of the new line m2, I should get -1, and so therefore m2 is going to be equal to -4 on 3, right? So -4 on 3 times 3 on 4 will give me -1, and so we have y is equal to the equation of the new line is -4 on 3x plus c. We still don't know what c is yet, but they did give us a point, right? So therefore Alright, at the point 6, 0 would imply, we could see here that x is 6, y is 0. So 0 is equal to negative 4 on 3 times 6 plus c. Alright, and let's come up here now and try to be much neater than me, please. Yeah, so now we could see here that 3 into 3, 1, 3 into 6 is 2, 4 2s are 8, so we have 0 is equal to negative 8 plus c. So therefore c is positive 8, hence the equation of the perpendicular line is equal to, or implies, y is equal to negative 4 on 3x plus 8. Okay, so we have a bit of an inequality question here. It looks like, draw the straight lines x plus y is 10 and y is equal to x on the grid below. Well, the line y is equal to x. Well, to draw any line, we just need 2 points. So let's just see the line y is equal to x. Well, we could say 0, 0. So we have the point 0, 0. That's now. So let's start with the line y is equal to x. So we could see here that 2 points would be 0, 0. We could use that as 1 point. And we could use 5, 5 as another point because it's y is equal to x, right? So 0, 0, 5, 5 is over there. And let me see if I could draw that line. Shape, line, nice, like that. And I'll see if I could extend it. Nope. That's not cool. Nice. So we have the line there. Oops, sorry. We have the line there, y is equal to x. And now we have the other line, x plus y is equal to 10. So x plus y is equal to 10. Well, when y is 0, x will be 10. So we have the first point, x is 10, y is 0, right? So when y is 0, x will be 10. And I'll put this in green here, right? And now when x is 0, y will be 10. So when x is 0, y will also be 10. So now I have this point there. So you see, to get 2 points, it doesn't really require any big set of working. You know, you just kind of have to use the equation as easiest as you can. And let's just draw another line here to represent that. Right. And let me just lengthen that line there. Oops, nope. Come on, man. Right. So now we have our two lines. Y is equal to x, and x plus y is equal to 10. So now let's see. That's 2 marks there. Wow, that's a lot of stuff for 2 marks. On the same grid, shade the region which satisfies the 4 inequalities. Okay, so I have 4 inequalities here, and I want to know which region satisfies all 4 of them. So I'm not going to start shading just yet, right? You can see that we have 4 quadrants here. We have this one, we have this one, this one, and this one. So I'm not going to start shading yet. I want to see which quadrants are true for all of them, right? For all of them. On the same grid, shade the region which satisfies all 4 of them, right? So let's try this first one. When x is less than or equal to 0. So which satisfies x being less than or equal to 0? Well, we could see here that anything on this side here will satisfy x is being less than or equal to 0. So we could immediately see that we are looking at this side of the grid, right? So we shouldn't be shading anything on this side because x is greater than 0 on that side, right? So x is less than or equal to 0 could only be true on this side of the grid, yeah? Y, wait, sorry, that's not less than, that's greater than. Grrr. All right. Right, so my mistake. So we can see here that the first one is x is greater than or equal to 0. So in terms of x being greater than or equal to 0, that means that we have x is 0 here. So x will have to be anywhere on this side of the grid. This is the only part of the grid where x is greater than 0, right? So we know that we are going to be dealing with this side of the grid and our region is not going to be here, right? So now we have to see which part of the grid is it true for y is greater than or equal to 0. And well, we can see here that y will only be greater than or equal to 0 above this line here. So we could see already that the region that we're looking for is going to be somewhere in this square over here. That will be the region that we're looking for. We still have 4 quadrants in that region, 4 different sections in that region, but at least we narrowed it down, right? X plus y, which is this equation here, but I only want when x plus y, that equation itself is less than 10. So what I do is I have this here, this green line here, and I will see, well, it have 2 sides to the green line. It have this side to the green line, and then it have this side of the green line. So one of those sides will have to be it. So I'll have to choose a point. Let's choose a point from this side, right? So I'll choose this point here being 5. And what does this look like here? We could choose any point actually. It doesn't have to be a point on the line, right? So let's just choose so 1, 2, 3, 4, 5, right? So this point here will be the point 5, and then that'll be 1, 2, 3. So we'll choose this point here, 5, 3. Right, just to make things easier, right? So choosing that point there, 5, 3, so 5 plus 3 is 8, and 8 is definitely less than 10, yes. So we could see here that we are dealing with this side of the green line inside of that little square there, right? And now let's see, so we know now from these 2, we narrowed it down to this square here, right? And then from this one, we narrowed it down to this little section over here. So now let's see what this guy says. X is greater than y. So x will always be greater than y on this side of the line, right? So you could see here that we could use anywhere to test it on this side to see that. And of course we don't want to go up here because that does not include the region that we want. We know the region that we want is below the green line. So therefore we have to see if it's here we want or here. So which one of those will x be greater than y? Well, we could see here that anywhere in this region here, like I have x is 5 and y is 3. So we could see here that x is greater than y over here. If I was to come in this region, I would have x being 1, 2, but then y would have been 5, you know, or that kind of thing. So over here we have y being greater. So we could see that the region that we want to shade is actually this region here. a regular polygon EFGHIJ, and I can see that there has center O, and the triangle OEF, I could see that there as well, is an equilateral where EF, an equilateral means all the sides are the same. So if this is 5, that means that this is 5, that means that this is 5. That's what an equilateral triangle is, right? What is the name of the polygon shown above? Well, it is a hexagon. Calculate the perimeter of the polygon. So the perimeter of the polygon, the entire thing, 5, 5, 5, 5, 5, 5, and of course a hexagon has 6 sides, 1, 2, 3, 4, 5, 6. So 6 times 5 is equal to 30 centimeters, and that is the perimeter of the polygon. Determine the size of each interior angle of the polygon. Determine the size of each interior angle of the polygon. So the interior angles of the polygon would be these angles here. And what are the size of those angles? Well, we know that this is an equilateral triangle, and one of the things we know about an equilateral triangle is that all of the angles are 60 degrees. That is one of the characteristics. 6 3s are 80. So if this is 60, that means that this will be another 60. So that means that this interior angle there will be 120 degrees, right? So so we could put here, in order to make sure that we get the 2 marks, right? That angles in an equilateral triangle equal 60 degrees each. Right? So therefore, at F, 60 plus 60 gives us 120 degrees. So each interior angle equals 120 degrees. Nice. Show by calculation that the area of the polygon to the nearest whole number is 65 centimeters, right? So the area of the polygon means that we would probably have to find the area of the triangle. And how many triangles do we have? 1, 2, 3, 4, 5, 6, because it's a hexagon, right? So we'll have to first find the area of the triangle. And it looks like the best thing that we could do here to find the area of the triangle is use our sine formula, because it's not a right angle triangle. We do have a perpendicular height. So we have this area here, area of a triangle is equal to a half AB sine C. And so we know that the sides are all 5 centimeters, and we know that it's the sine of 60 degrees. So that means that we have 5 times 5 is equal to 25, multiplied by 0.5 is equal to that, multiplied by the sine of 60 degrees is equal to approximately 10.8253. Right? And this is the area of one triangle, centimeter squared. So this here is the area of one triangle. Therefore, area of the polygon is equal to 10.8253 multiplied by 6. And you can see in this situation here, when we're dealing with sine of 60 and all of these kind of things, that it's probably best to work in decimals. You probably wouldn't be able to get a fraction there, because the sine of 60 is 8.66. It's an irrational number essentially, right? 0.866 going on and on. So we have here 10.8253 times 6, and that is 64.9518 centimeters squared, and we could say approximately. Nice. A water tank has a cross section with dimensions identical to the polygon. Okay, so remember that. So we have the area of the polygon and all of that, right? The water is poured into the tank at a rate of 75 cubic centimeters per second. After 52 seconds, the tank is a little bit full. Determine the capacity of the tank in liters. So we are asked to determine the capacity of the tank in liters, right? So the volume that the tank could hold. But the thing is that we do not have the height, we have the area, and this area is approximately 65 is what we got here in this last one. So we have the area there, and maybe we might need it, maybe we might not even need that, right? So at the end of the day, let's see what we have. Yeah, we have the water is poured into the tank at a rate of 75 centimeters cubed per second for 52 seconds. So for 52 seconds at 75 centimeter cubed per second, that means that the tank presently has 3,900 centimeter cube in terms of the volume of the tank, right? Now we could see here that 3,900 in terms of the volume of the tank, centimeter cube, that is 2/5 of the height. So if it's 2/5 of the height, it's also 2/5 of the volume. So 2/5 of the volume of the tank is 3,900. So therefore, the full volume of the tank will be 5 on 2 multiplied by 3,900. When we carry the 5 across, it becomes multiply. When we carry the 2 across, it becomes divide. Yeah. So now we have 3,900 multiplied by 5 divided by 2. And now we get 9,750 centimeter cube. This is the full capacity of the tank, if the tank was full. So you see, we didn't even actually need the area, right? And so if this is the full capacity of the tank, in liters, what do we have? 1 liter is 1,000 cm cube, right? So therefore, 9,700 cm cube, 1, 2, 3, we will end up with 9.75 liters. So we now have to calculate the height in meters of the tank. So we can see here that the volume, and now we'll need the area, because the volume is equal to the area, which is 65 centimeters squared multiplied by the height. And we worked out the volume. This will give us the volume in centimeter cubed. So we will use the volume in centimeter cubed, which is 9750. So we have now 9750 is equal to 65H. Therefore, H is equal to 9750 divided by 65, which is about 150 centimeters. The diagram below shows triangle PQR. State the coordinates of R. Well, we could see here the coordinates of R, that is the point R, and we will have it's about 3 on the y-axis, but it's 0 on the x-axis. So the point R is the point 0, 3. The diagram above triangle PQR prime, a reflection of PQR in the line y is equal to 1. So the line y is equal to 1 is actually the horizontal line here, because on this line y, the y value will always be equal to 1 no matter what x is, right? So therefore it's a reflection in this line over here. So it being a reflection in this line means that this will be the point P prime. All right, 1, 2, 3. 1, 2, 3. This will be the point Q prime. And then R will be 1 up from P. You have R. So 1 up from P, you'll have R over here, R prime. And this here will be the triangle whose reflection is in the line y is equal to 1. And of course, you guys are expected to use a ruler, please, right? And now we have to draw an image, a reflection of that last image. So the triangle double prime being a reflection of the prime triangle in the line x is equal to 0. X is equal to 0 is this y-axis here. This is the line where x will always be equal to 0. And so we could see here that we have, this will be R double prime. This will be P double prime. This will be Q double prime. And this will be our reflection. So the double primes being a reflection of the primes, and the primes being a reflection of the original triangle. Describe fully the single transformation that maps PQR prime onto PQR. Alright, so what maps the second image back to the original? So we could see here that if we look at the R's, we have this point R and we have this point R double prime. Yeah, and we draw a line from there to there, and we could see that the midpoint of that line is that. So we could tell that to get from R double prime to R, we would need to rotate anti-clockwise about 180 degrees. So therefore, triangle PQR double prime maps onto triangle PQR, the original image, by a rotation anti-clockwise about the center point. And that center point is this point here, which is the point and in the middle of R and R prime, and that point here is the point 0 on the x, 1 on the y, so that is the point 0, 1. The triangle PQR undergoes an enlargement of a scale factor to calculate the area of its image. So we first have to calculate the area of PQR. So we could see here PQR has a perpendicular height of 1, 2 units and a base of 1, 2, 3 units. So the area of PQR will be a half the base, which is 3, times the perpendicular height, which is 2. 3 2s are 6, and a half of 6 is 3. So therefore, area of enlargement will be 3 multiplied by the scale factor of 2, which will be 6 centimeters squared, or actually let's just put, because we don't know if it's centimeters on the graph paper, so I'll just put units squared, right? Whatever units are on the paper, because they did not specify if it was centimeters or what. The marks obtained by 10 students in a test scored out of 60 are shown below. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students, and these are their marks out of 60. Right? For the data above, determine the range. So the range will be the lowest mark being subtracted from the highest mark. So 29, it looks like 26 now. And anything lower than 26, no. So 26 is the lowest mark. The highest mark is 38, 45. Yes, 45 is the highest, so 45. So the range gives us 45 minus 26, which is 19. So everyone scored within a 19 mark range. The median. So in order to find the median, I'm going to need to put all of these guys in numerical order. So 26, 29, 31, 35, 37, 38, 38, 38, 3 38s, 37, 38, 38, 38, then 42 and 45, 42 and 45, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and with the median, I am going to take these 5, and then these 5 are gonna look at these 2 in the middle here, because it's an even number, means I don't have one number in the middle, I have 2. And so I'm going to need to take these 2 and divide it by 2. So 37 plus 38 divided by 2 will give me 37.5. So the median is right there in the middle. The interquartile range. So we can remember that if this median is Q2, then we could see here, well, if we take a look at this 5, in the middle of this 5 here, we'll have Q3. And then in the middle of this 5 here, we'll have Q1. And so the interquartile range is Q3 minus Q1, which is 38 minus 31, which is 7. The probability that a student chosen at random scores less than half the total marks in the test. Right? So the probability that a student chosen at random scores less than half the total marks in the test. So the test is 60. So half the total, half of 60 is 30. So I have to look at all of the students who scored less than 30. So we could see here that 2 students out of 10 scored less than 30. So therefore the probability of students scoring less than 30 will be, well, we have 2 scoring less than 30 out of 10. So that means that is a 1 in 5 probability that we will get somebody who scored less than half of the marks. The frequency distribution below shows the masses in kilograms of 50 adults prior to the start of the fitness program. Okay. So we can see here this frequency here is a frequency distribution, and if we do a cumulative frequency, we should get 50 at the bottom here because it's 50 adults, right? On grid on page 23, using a scale of 2 centimeters to represent 5 units on the x-axis, 1 centimeter to represent 1 unit on the y-axis, draw a frequency polygon to represent the information on the table. Well, first of all, let's see these units. 2 centimeters to represent 5 units on the x-axis, right? So on the x-axis, 2 centimeters to represent 5. Now remember, when we draw in a frequency polygon, always keep in mind that the frequency is going to be on the y-axis and whatever. So this is going to be on the y-axis. So therefore the mass is going to be on your x-axis, right? And of course this midpoint here really just gives us the midpoint of the class interval. So we could actually put these midpoints here. Well, I wouldn't put the midpoint actually, because you can see that we have the lowest one. So we'll start at 60, right? And we could be prepared to maybe end at 90 up here, right? In terms of the mass. And then in terms of the frequency, we'll start at 0 because we can see that we have very low values, and we go all the way up to 15, so we can have 15 up here. Right? So 2 centimeters to represent 5 units on the x-axis. If we are starting at 60, right? On the x-axis, this would be 2 centimeters to represent 5 units. So 1, 2, right? So we can have 60, 65, 70, 75, 80, 85, 90, right? And then on this here we have 1 centimeter to represent 1 unit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 and 15. And of course we should label it frequency F, and mass in kilograms here. So now let's plot our points and see how we're going to plot our points. And in order to plot our points, we can actually use this midpoint. So 62 is going to go to 8 on the frequencies, right? So I have here 60, this will be 61, this will be 62, and 62 will go all the way up to 8. So I have my first point here. And then what do we have? 67 going to 11. So 65, 66, 67 going to 11, which is about here. '72 goes to 15. So 75, so 70, 71, 72. Where is 72? 72 is there. Going to 15 will be about here. 77 going to 9. So 75, 76, 77 goes to about 9, which is here. 82 goes to 5 and 87 goes to 2. So 82, 1, 2 goes to 5, and 85, 6, 7 goes to 2. So now this is kind of what our frequency polygon is going to look like, and we should join these things with as straight lines as possible. So let me try to use my straight line tool here, and we'll go from here to here. Now this is essentially what our frequency polygon should look like. However, I would like to change this to come up to 1, because if it starts at 0, it would imply that 0 people, like if we put this at 0 here, right, then 0 people has a mass of approximately 50 kilograms, and that makes no sense, right? So I will actually start it at 1 here and go up and come down, and our frequency polygon should look something like this. Sequences. So a sequence of figures is made from toothpicks of unit length. The first 3 figures in the sequence are shown. So we can see here, draw a figure for the 4th figure for the sequence. Well, we could see here that the first figure is 1 at the base, the second figure is 2 at the base, the third figure is 3 at the base. So the 4th figure should have 1, 2, 3, 4 at the base. And we will draw the first triangle here, second, third, 4th triangle, and then we'll just have these joining here, and this is what your 4th figure should look like. Study the patterns of the numbers in each row of the table below, and in each row relates to one of the figures in the sequence. Some rows have not been included in the table. Complete the rows numbered 1, 2, 3, and 4. We have the marks here. Now we can see here that we have the figure, the nth figure. So we will need to find the number of toothpicks and the perimeter of the figure. We will need to find an n sequence for that. And I usually like to do that first because that helps us to find all of the other answers, right? So let's start with the number of toothpicks. And we can see here that when we have the sequence, the n values being 1, 2, 3, and then we have the actual sequence or the pattern, and that pattern goes 3, 7, 11, dot dot dot. So we want to know what we will have for the nth, right? So remember, I am going to put n by each one of them over here because I'm going to have to do something to this in order to get n. I'm going to have to do something to n in order to get this number here. So if n is 1, right, and I'll actually put the n value, instead of putting n, I'll actually put the n value. So this is 1, 2, 3. What am I going to do to 1 in order to get 3? Well, I can multiply 2 plus 1. So 2 times 1 is 2 plus 1. All right. 2 2s are 4 plus 3. Well, it doesn't really help. 2 3s are 6 plus 11. 6, 7, 8, 9, 10, 11 plus 5. No, this sequence does not really help us. So let's try something else. Right? So let's go. I'm gonna have my n values here, 1, 2, and 3, and let's try multiplying by 3 this time. So 3 1s are 3, 3 2s are 6, plus 1 is 7, 3 3s are 9, plus 10, 11. So this gives us something a little easier to work with, right? Because I could see here that I have to multiply by 3, and I'll have to multiply by n, and I'll have to add some number. And this number here is actually 1 less than n. So I'll have to add n minus 1. And now if we expand this, we can see that 3n plus n is 4n minus 1 is the actual sequence here. And if we really check it, 4n minus 1 really does give me 3. And so we have 4n minus 1 being the final answer, 4n minus 1 here. And now let's take a look at this sequence over here. We can see that they already started to give us some clues. And we could also see, let's look for n. Look, we could see n here, 1, 2, 3. So whatever it is, it's going to be n plus 2. And look at this. This guy here is 1 less than n, isn't it? Whatever n is, this one is 1 less than n. So plus, on this side I'll have n minus 1. Right? So n minus 1 plus n plus 2. So n plus n is 2n, and 2 minus 1 is 1. So we could see we end up here getting 2n plus 1. And now that we have our sequence, we can figure out everything else that they want us to find. So for part 2, this will be, we could see here that in this case n is 20. So if n is 20, that means that 4 times 20 minus 1, 4 2s are 8, so that's 80 minus 1 is 79 over here. For part 3, if this is 127, right, so that means that 4n minus 1 gives me 127. So 4n is equal to 128. I throw the a minus 1 across. And n is 128 divided by 4, which is 32. So here we have n as 32. And now over here we could see that this will be n plus n minus 1 plus 2, which will be 31 plus 32 plus 2, and that is 65. And I believe that we did cover everything here. And now we are in section 2. Show by calculation the exact roots of the quadratic equation R. Right? So we have a quadratic equation and they give us this as the roots. And you notice they say they use the word exact because you'll see that if we look at the square root of 6, the square root of 6 is 2.449 blah 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 to infinity. So you know, that's why I say we don't really like in mathematics, we don't like decimals that much. We actually prefer, if you want an exact answer, you can leave it as a third, you can leave it as a fraction, and you actually have a more exact answer here. We could also see that this plus or minus means that we could use the quadratic equation for this, right? So let's try using the quadratic equation. So recall, the quadratic equation is minus b plus or minus the square root of b squared minus 4ac all over 2a. We can see here this is a, this is b, and this minus 5 is c. So that implies that b minus b plus or minus the square root of b squared minus 4 into a into c all over 2 into a. Right? And it's starting to come together already, so we could see that this is minus 2 plus or minus the square root of 2 2s are 4, 5 4s are plus 20, right? Because the double negatives there divided by 2. So that means that I have negative 2 plus or minus the square root of 24 all over 2. So that gives me negative 2 all over 2 plus or minus the square root of 24 all over 2. So if we take a look at the rules for this square roots, right, we could actually see that the square root of 24, we could actually see that the square root of 24 is the square root of 6 multiplied by 4. And we could actually split this up because this is 6 to the half times 4 to the half, right? So we can actually split this up to give us the square root of 6 times the square root of 4. Right? And we know that the square root of 4 is 2. 2 2s are 4. So therefore the square root of 24 is the same as 2 root 6. Yeah. So now we will have this working out to be -1 plus or minus 2 root 6 all on 2, and these 2's will cancel, so therefore we have -1 plus or minus the square root of 6. So this here is a nice little surds exercise for you to try to make sure and remember, so you can mark this off. Hence or otherwise solve the simultaneous equations. Well, they say hence x squared 2x plus 5, and well, this is the root of this equation, so I don't know how that is going to help me, but let's see, right? So hence or otherwise solve the simultaneous equations. Well, let's try. We'll call this equation 2, we'll call this equation 1. So therefore from equation 1, x is equal to y minus 2 in equation 2. So that implies that I'll have x, which is y minus 2, multiplied by y is equal to 5. So therefore y squared minus 2y minus 5 is equal to 0. Yeah? And of course here I could find two values. So what values that when I add them I will get -2, but when I multiply them I'll get 5. It doesn't really seem to have anything, but plus 2x minus 5. Let's try something else. Let's try instead y is equal to x plus 2. So we'll just sub 1, y is equal to x plus 2. And we'll sub that in 2, and let's see. And I could see now why they say hence or otherwise, right? So y is equal to x plus 2, and we subbing it in 2. So we could see here that x times y, which is x plus 2, is equal to 5. Therefore, x squared plus 2x minus 5 is equal to 0. And now we could see that this is pretty much the same as this. And so this is the actual answer. X could be, therefore, x is -1 plus the root of 6, or -1 minus the root of 6, right? So now we can actually put this into the equation to solve for y. So therefore, when x equals -1 plus the root of 6 implies y is going to be equal to x -1 plus the root of 6 plus 2. So y is going to be 2 minus 1 is 1 plus the root of 6, and I'll just leave it like that. And when x is equal to -1 minus the root of 6, that implies that y is equal to, and I'm subbing it back into this, x -1 minus the root of 6 plus 2, which is 1 minus the root of 6. So yes, hence and otherwise it did work out. You can see that I tried something at first and it was looking similar to the last one, but it had y's in it. So I decided to try something where I will end up with x's, and hopefully it would have looked like this, and it did. And so because it looked like that meant that I had the roots already, and so I was able to find the corresponding values of y quite easily, right? The incomplete table below shows values of x and y for the function y is equal to 2 to the power of x for integer values of x from -1 to 4. So when x is -1 to 4, we have to complete the table, of course. So we see here that when x is -1, so 2 to the power of -1, and you can actually use your calculator, but you don't really have to use your calculator. Remember, this is 1 all over 2 to the power of 1. So we could see here y is a half, right? We could see here that when x is 1, it'll be y will be 2 to the power of 1, which is 2. We can see here that when x is 2, y will be 2 squared, which is 4. So x will be 4. 2 cubed is 8, and 2 to the power of 4, 2 2s are 4 2s are 8 2s are 16. Okay. So on the grid provided on page 27, draw this graph using the scale of 2 centimeters to represent 1 unit on the x-axis, 1 centimeter to represent 1 unit on the y-axis. So I started from -0 and I'm going to 4 on the x-axis. So let's see. They say 2 centimeters. So from this 0 here, if I do in 2 centimeters, then this will be 1, 2, 3, 4, and this will be -1. And then 1 centimeter on the y, well, I'm going from 1 to 16. So wow, that's a lot of writing there. So that means that this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Remember, please, to label and draw these arrows there, or they already have the arrows. So that is pretty cool. So these are your y values, and these are your x values. And let's check it out. We saw that when x is -1, y was here. When x was, did they have x is 0? Yeah, x is 0. And we saw that y was 1. When x is 1, y is 2. When x is 2, 2 squared is 4. When x was 3, y was 8. And when x is 4, y was all the way up here to 16. So we have a bit of a curve, and this curve looks like this. Nice, right? So it should look something like that. I hope you guys could draw it a little neater than me. And drawing the appropriate lines, determine the value of x for which y is equal to 11. So you want to know what is the value of x when y is equal to 11. So when y is equal to 11, and of course my graph is a little bit bent and skewed, so maybe, you know, maybe I might get a slightly different answer from you. And if you guys, and let me see if I could draw my graph a little smoother so I'll get a little bit of a better answer. But you know, if you guys don't get exactly the same answer, that is okay. Once you are in the ballpark of a certain kind of answer is what they're looking for, right? Right, and I could see that when I draw my graph a little better, it does kind of clip right here. So I'm just going to use that point there. And of course, if you got a little bit before or a little bit after, that is fine. They will have some margin of error here, but we could see here that this is about 3.5. So we could see here that x is approximately 3.5. So that was our quadratics question. Now let's take a look at the circle theory question. And the diagram not drawn to scale shows the circle 0, points A, B, C, circle with center O, sorry. Points A, B, and C, everything is shown there. We could see that we have two tangents to the circle at A and D respectively. And I'm remembering here that this here will from O, this is my radius, and I'm remembering that this to the radius to the tangent is always 90 degrees. So I'll have 90 degrees here, and I'll have 90 degrees here, right? And we could see that the center is 114 degrees here. We have 18 degrees outside here. All of these things are shown. Calculate, giving reasons for each step of your answer, the measure of A, C, D. So A, C, D. So ACD is this angle over here. And if we notice, this ACD is subtended by this chord. And we'll also notice that the angle at the center is also subtended by that same chord. So therefore, the angle at the center will always be twice the angle at the circumference. So ACD will be 114 divided by 2. 114 divided by 2 is 57 degrees. And always put the angles at the center is twice the angle at the circumference, subtended by the same chord. Nice. AED this time. So we have AED. Oh, that's this one over here. So one thing we could remember is that when tangents meet at a point, then these two are equal. So if these two are equal, this forms an equilateral triangle. That means that this here, because of the radii, this is also an not an equilateral, sorry, isosceles, right? So this is an isosceles here, and this is also an isosceles here, and they both share this side over here, right? And they both form a quadrilateral. And we know from a quadrilateral that the opposite sides, opposite angles of a quadrilateral, and in this case it's a kite, if you would notice, right? So the opposite sides of a quadrilateral add up to 180 degrees, right? So triangle AED will be 180 degrees minus 114 degrees, and that will be 66 degrees, because AED plus AOB, this is the 114 degrees, is supposed to give us 180 degrees, because opposite angles in a quadrilateral are supplementary. They add up to 180 degrees, right? We have OAC. So the angle here, we are going to find OAC, and that is a tiny angle there, OAC. So from O to A, and then to C. So that is a really tiny angle there. So let's see how we could find this angle. Well, I know that this here is an equilateral, right? So that means that, you know, these two angles here are going to be 33 degrees each. How did I get 33? Because remember, there are 180 degrees in any triangle, and this is 114. So 180 degrees minus 114 gives me 66. That's what we just put here. So 66 means that 33 each, right? Now this angle here is actually 18 degrees, right? This angle here is actually 18 degrees. Why? Because look, we have here the chord that is forming this 18 degree angle with the tangent, right? And we have the rule that the angle formed subtended by a chord, right, in the alternate segment is going to be equal to the angle between that chord and the tangent, right? So this is 18. So therefore this tiny little angle here will be the 33 minus 18. So 33 minus 18 gives us 15 degrees. So that little angle there, the angle AOC, is equal to 15 degrees. Why? Because triangle, so because we could say the angle AOAD is 33 degrees. So let's go with that first. Angle OAD equals 33 degrees because equilateral. Triangle OAD or AOD, right? So AOD or OAD is an equilateral triangle, so therefore OAD is 33 degrees, that angle particularly, right? And the angle CAD is 18 degrees. Angle CAD equals 18 degrees. And why? Because the angle subtended by a chord in the alternate segment, right? Alternate segment to the tangent, which is 18 degrees, right? So the tangent is forming this 18 degree here, so that means that this tiny little thing is going to be 18 degrees, and hence we will have 15 degrees there. That was actually quite a tough one. And then we have ABC. So the angle ABC, which one is that? ABC, ooh, that's that one here. And we can see that we have a cyclic quadrilateral. And in terms of the cyclic quadrilateral, this is 18. We know that this is 90. So a 90 minus 18 means that this angle here is 72. This here is 72. We know that this is 33. So 72 plus 33 is equal to 105. So this here is 105. This angle here is 105 degrees. So the angle ADE is 105 degrees, and opposite angles in a cyclic quadrilateral are supplementary. They add up to 180 degrees. So 180 minus 105 gives us 75 degrees over here, right? So we have 75 degrees, we have 105 degrees over here. So the angle ABC is 75 degrees. And the reasons that we will put that ADC is 105 degrees. Well, first we'll put ODC, angle ODC is 90 degrees minus 18 degrees, which is 72 degrees, and the reason being that angles with the radius and tangent equals 90 degrees, right? So we have the angle ODC gives us 72, and therefore from that we get ADC being 105, right? So therefore angle ADC is 72 plus the 33, and that gives us 105 degrees, and hence ABC is equal to 180 minus 105, which is 75 degrees. And why? Because opposite angles in a cyclic quadrilateral are supplementary. Nice. So the diagram below shows a cuboid. We have the dimensions of the cuboid. Give your answer to correct to 1 decimal place. Write a straight adjustable wire connects point R here to point P along the top. Alright, so we have a straight adjustable wire connecting point R to point P. Calculate the length of RP. Well, we can see here that this is a straight Pythagoras theorem question. This is 100 cm here. This is 60 cm here. So therefore PR, or we could call it RP since the question calls it RP. RP squared is equal to 100 squared plus 60 squared. So RP is going to be the square root of 100 squared plus 60 squared, which is 13,600. So therefore the square root of that is about 116.62. Yeah, calculate the length of the wire, and they did say correct to 1 decimal place, so let's call it 116.6 centimeters, right? The connection at P is now adjusted to move to T. Calculate the length of RT. So we actually did a question like this in class, right? So we actually gonna move here from R to T. So this is a 3D kind of thing. So from R to T, yeah, and we have to imagine this in 3 dimensions. So this thing is going across the center of the room, yeah, and we actually did a question exactly like this in class. So we know this length here. We know this length is 116.62. We know over here is 20. So this forms a right angle triangle at the center of the room, right? Where this is running along the roof. And then we have from here we have a side coming down to the ground from the ceiling there. So you could imagine a piece of cloth being tied from this wall and you're carrying it up to this point there in the ceiling. We could see here that because this is on the ceiling, that this will form a right angle triangle. And so we're dealing with another Pythagoras question here. So TR or RT is going to be the square root of 116.6 squared plus 20 squared. So that is going to be 116.6 squared plus 20 squared is the square root of 13995.56, which is square root of the answer, approximately 118 to 1 decimal place 0.3 centimeters. Calculate the angle TRV. So TRV, that's interesting, right? That is interesting indeed. So TRV is this angle over here, right? This is the line that is going from R to T, and let me do that line in red instead, from T to R. So we have this angle here from T to R, and it's a bit tough to visualize this, so I hope that you guys are going okay. So we could see here that if we do this and this, right, we have a red right angle triangle here, where we know the base will be parallel to the one on top. So this base is going to be 116.62, right? And we just worked out the hypotenuse, and the hypotenuse is 118.3. We know that this height here is 20, and this is a right angle triangle. So we could use some trigonometry here. So we could use SOHCAHTOA, and I'd like to use something that have the 20. So this 20 would be an adjacent, so maybe we could use cos. Alright, cos of this angle, that angle at R is going to be the adjacent, which is 20 over the hypotenuse 18.3. So let's just say that the cosine of TRV is equal to adjacent over hypotenuse, which is the adjacent is 20 all over the hypotenuse being 118.3. So that is 20 divided by 118.3 gives us 0.1691. So therefore TRV is equal to the cos inverse of 0.1691, and that gives us cos inverse of the answer gives us about 80.2, or if they wanted to 1 decimal place, it would be 18.3 degrees. 80.3 degrees. Complete the following statement. The size of the angle through which the wire moves from RP to RT is. Right. So when you're moving, like if you move the wire going from R to P, and then if you move the wire to T, it going through this angle here. So that angle will be 90 degrees minus that 80.3. So 90 minus 80.3 is 9.7 degrees. and the angle which is the same size as RTV is. An angle which is the same in size as RTV. So RTV is which one? RTV. Right? So if you notice, this here, this PR is parallel to this bottom here, which is TV. Yeah? And we just saw that this angle here, right? So we have PR and then this hypotenuse here, which is like a transversal between this other parallel line here. So we have these two lines here being parallel, these two top lines here being parallel, and then we have this transversal in the middle here. And of course we just worked out that this angle here is what? 9.7 degrees. Yes. So an angle which is the same as RTV. So RTV is here. And we can see here that PRT is the same. So this here, you see how this here is 9.7, this angle here, PRT. Well then, this here will also be 9.7 RTV. So therefore, is PRT, the angle PRT is the same, which is 9.7 degrees. All right. And now we have our final question here for the night, which is vectors and matrices. So given the vectors, we have vector OP, which is a position vector. Once you see that O, that means it's coming from the origin. So that's a position vector. PQ is not coming from the origin, or RS is not coming from the origin. So you could think about these guys as translations. But once you're coming from the origin, you can actually think about this guy as a point. Determine OQ. I always like to draw a sketch. So let me just draw this sketch on this side here. So I see in that OP is 1, 2, 3, 1, 2, 3, 4. So that is over here. That is the point P. This is O. So this is my vector OP 3, 4. And then from 3, 4, well, P to get to Q, I have to go -1 here. And then I have to go up to 1, 2 over here. So that means that this here will be Q. And so Q will actually be the point, and I'm working it out here. If I go -1 from 3, it'll actually be the point 2. And then from 4, I'm going up 5, 6, it'll be the point 6. Right? Because the translation from P to Q is -1 and then 2 up. You could see it here, right? And R to S is 1, 3. Well, I don't know where R and S are in this diagram. So I want to determine the vector OQ. So the vector OQ is actually that vector 2, 6, right? So how do we get 2, 6? How do we get OQ? Well, we could say that the vector OQ, how did we get that? We took the point P and we added the vector PQ. Right? So the point P was 3, 4. And remember, we can call it a point P because it did come from the origin as a position vector, plus the PQ, which is -1, 2, will give us the point Q, right? Which is 3 minus 1 is 2, as we already worked out there, and 4 plus 2 is 6. Therefore, OQ is the vector 2, 6, sorry. Show that OQ is parallel to RS, giving reason for your answer. Well, OQ is 2, 6. And RS is 1, 3. So therefore, we could see here that if we take RS and we multiply it by 2, right? So OQ is really 2 multiplied by RS. So therefore, they are parallel. Yeah, because they are scalar multiples of each other. XYZ is a triangle and M is the midpoint of XZ. Okay, so let me just draw a triangle. XYZ. I don't know what the triangle looks like, but I'll just draw X, Y, and Z. And they say M is the midpoint of XZ. They say XY, and you notice the direction from X to Y, that is this direction, and we're calling it A. And then from Y to Z, that's this direction, we're calling it B. Express the following vectors in terms of A and B, simplifying your answers where possible. X, Z. So if I want to go from X to Z, I have to go from X to Y and then Y to Z. So XZ is equal to XY plus YZ. So XY is A plus YZ is B. So therefore XZ is equal to A plus B. MY. So MY. So from M to Y, I will have to go from M to Y. I would have to go from M to X and X to Y. So from M to X plus X to Y. Now I already saw that XZ in this direction, A plus B. So in that direction, it'll be minus A plus B, and it'll be minus a half of that because we're going from the midpoint M, right? So therefore, MX is negative 1/2 A plus B plus XY, which is A. So what do I have? Negative 1/2 A minus a half B, yeah, plus A. So what will I get? A minus 1/2 A is positive 1/2 A minus 1/2 B, and you could leave that as your answer, or if you want, you could pull the half out and factorize it as A minus B. So we now have the matrices A and B are given as these here. Determine the inverse of A. Right? A inverse. So A inverse is equal to 1 all over the determinant of A multiplied by A adjoint. So first, let's get the determinant of A. And the determinant of A is negative 1 times 2 minus 0 times 3. Right? So that gives us negative 2. And A adjoint is when we flip to negative 1, and then we put negative signs, 3, negative 3, and well, 0 would make sense putting a negative sign in front of that. So this is A adjoint, so therefore A inverse is equal to 1 all over negative 2 multiply by 2, 0, negative 3, negative 1, and we could actually leave it like that. I mean, if that 1 over 2 could have gone into everything nicely, then you know, we would have, but you know, it actually looks a lot neater this way, right? Show that A inverse times A is equal to 1. So we have A inverse 1 negative a half into 2, 0, negative 3, negative 1. And we multiplying it by A, which is negative 1, 0, 3, 2. And I'm just gonna multiply my matrices first, and then so I'll leave in the determinant outside at negative a half. So what do I have here? 2 times negative 1 is negative 2, plus 0 times 3 is 0. 2 times 0 is 0, and 0 times that 2 is 0. Right? Negative 3 times negative 1 is positive 3, and negative 1 times that'll be plus negative 3, and then over here I will have 3, negative 3 times 0 is 0, and then I'll have negative 2, negative 1 times 2 there. So what do I end up with? Negative a half into negative 2, 0, 0, negative 2. And now we could easily see that that is equal to this negative a half. The negatives will cancel. 1, 0, 0, 1. And that is our identity matrix. Determine the matrix A squared. And I don't think we actually covered this one in class, but it's actually quite easy. A squared is if we take the matrix A, which is negative 1, 0, 3, 2, negative 1, 0, 3, 2, and multiply it by itself, negative 1, 0, 3, 2. So what do we get? Negative 1 times negative 1 is positive 1, plus 0. Negative 1 times 0 is 0, plus 0. Negative 3 and 3 2s are 6, and then we have 0 plus 4, 3 times 0 and 2 2s are 4, so we are going to end up here with 1, 0, 3 and 4. And this here is the A squared. So when you have A squared, you're basically taking the matrix A and multiplying it by itself. And explain why the matrix AB is not possible. So you can see here that A is a 2 by 2 and B is a 3 by 2, 3 rows and 2 columns. So we could state that A is equal to a 2 by 2, B is equal to a 3 by 2, therefore they cannot be multiplied. Okay? Without calculating, state the order of the matrix product BA. Without calculating, state the order of the matrix product BA. So what is B? B is negative 3, 2, 1, 1, 4, 6. Negative 3, 2, 1, 1, 4, 6. And then the matrix A is negative 1, 0, 3, 2. Negative 1, 0, 3, 2. Now at the end of the day, this is a 1, 2, 3 by 2, and this is a 2 by 2. So state the order of the matrix. The order of the matrix. You don't actually have to calculate anything. So we could see here that once these two are the same, the order of the answer will be these two. This would be a 3 by 2 matrix, right? And that is it for January 2018, paper 2. I hope that you guys understand everything, and if there are any problems or any questions, you can always contact me on either in class or on WhatsApp.